So our next speaker today then is Leo Hergenroder from Alakai, speaking about Alakai's safer and Argus standoff detection sensors. Leo?
Hi, I'm Leo Hergenroder. I'm the Chief Growth Officer for Alakai Defense. We have developed a couple of products that we think are of particular interest to first responders, and I'll explain why. But we have standoff detection, the only sensor with good standoff detection for chemical warfare agents, for explosives, for narcotics, and for ticks and TIMs. So, can I go to the next slide, or?
Sorry about that. You'll need to take control, Leo.
Okay.
It'll be in the upper left, roughly.
Where it says share?
Where it says take control.
Got it.
Yep. Then you should be able to advance the slides.
Okay.
You should be able to advance the slides. There should be on the bottom left.
Yep, got it.
Perfect.
Okay, so the standoff threat detection, basically we give you a safe distance from the threat chemical. So in 2016, DHS evaluated our backpack system, which is called Pride, which you see there. It is a 31-pound system. And they said, oh, this is good technology. We love the standoff. We love the detection of the different chemicals, but it's too big. We want it to be smaller. So over the next few years, we have developed two products. One that is available in September for production, which is called Safer Standoff for first responders. And the second one called Argus, which is a higher performance version of the Safer product. The benefit of standoff is probably obvious to all of you, but if you have a threat chemical and you're not quite sure what it is, the last thing in the world that you want to do is get up close to it, take a little bit of it, put it in a vial, and then put it in an analyzer to determine what it is. So we allow you from distances of 5 to 10 meters with these two handheld products and longer distances with our other larger products to determine what the chemical is and what you should do about it. We think that this is going to be of particular interest to law enforcement, first responders, to survey teams, and to the FBI and the State Department. So what's the need that we're trying to meet? We need fast and accurate chemical identification. So here you can see the spectra, and this is about as scientific as we're going to get today. For ammonium nitrate, for example, in the upper left-hand corner, you can see the chemical spectra, and you can see the Raman spectra. So basically what we do is we shine a ultraviolet laser beam at the chemical. It excites the chemical and it emits a Raman spectra, which comes back and is analyzed by our unit. So the four chemicals that you see here are ammonium nitrate, CDMEA, which is a surrogate for chemical warfare agents that's used, a simulant, hexamine, which is explosives precursor, and potassium chloride. Okay. So what do we want the units to be able to do? We're looking for greater than 95% probability of detection when we look at a chemical. We want the false alarm rate to be less than 5%. We'd like it to detect mixtures. So particularly if you're looking at drug applications or a lot of homemade explosives applications, they're usually not pure chemicals. There's often 2 or 3 components, and we want to be able to identify all of those. Real-time results, the algorithm that we have developed will do the classify the spectra in less than a second. And we want it to scale to large libraries. So we have scaled it with simulated data to a library that contains greater than 2,000 chemicals. The development time is less, and we want one model for all the different serial numbers. In other words, we don't want to take each Safer or each Argos and individually shoot all the spectra with it. We want to be able to transfer the spectra from serial number to serial number. So the result of that is AMPS. So AMPS is called the Agnostic Machine Learning Platform for Spectroscopy. And here you can see the SAFER. This is the older form factor of the SAFER. And this algorithm was developed under the SBIR for DHS S&T. So it takes the spectra from the chemical. It is processed by a single board computer that is on the SAFER or the Argos. And then it does, with the AMPS algorithm, it matches the spectra to the particular chemical spectra of interest and displays the results. Now on SAFER, it's displayed on a phone, and on Argos, it is displayed actually on a heads-up display that's on the back of the unit. So what's special about AMPS? So it is a machine learning algorithm, and so it's different than the algorithms that Alakai Defense and frankly most other spectroscopy companies have used over the last 20 or 30 years, where you're basically trying just to match peaks. And they're very cumbersome. They're easy to kind of fool. The false alarm rates can be higher. You have to tune them quite a bit. The interesting thing about AMPS, because it's machine learning, it accelerates the sensor development, and it also accelerates the accuracy of the algorithm. It also does a much better job with mixtures than previous algorithms, the bulk force algorithms, and it creates models for sensors that are in production, and gives us good real-time threat detection. So the AMPS algorithm, and you'll see on some slides that I'm going to show you in just a little bit, that we spend less than 6 seconds usually looking at a threat chemical before we know what it is. And it tells the operator that you don't have to shoot this with the laser anymore. We've identified the chemical that you're interested in. So where are we on AMPS? You know, we had the SBIR. We've developed the algorithm for SAFER. We are looking at moving that algorithm from SAFER to some of our other sensors, in particular Argos. So the AMPS algorithm is a TRL7. The first production units that I mentioned of SAFER are coming out in a few months with the AMPS algorithm on them. And then we are transferring that to the Argos prototype. We also would like to take AMPS and use it to look at other sensors, and also with the possibility of fusing the data from multiple sensors so that we can get even better results. And that's the primary application that we're looking to have funded here for the future development or continuing work. So here is a kind of a summary chart of Alakai's products. So we do solids and liquids. We do not do gases, with some very small number of exceptions, or vapors. We do different limits of detection. So Pride, the 31-pound unit that we kind of started with, does what we call invisible trace. So if you were to go to our website, you could see, for example, a video of people at a checkpoint looking for invisible trace of explosive chemicals on the door handles or tailgates of a vehicle, on the palms or fingerprints of the person that's driving the truck. Invisible trace is the same level of chemical that when you go through a TSA checkpoint, for example, and they pull you aside and they take that little swab and they run it over your fingers and over your luggage, and then they put it in a large, stationary spectrometer there. That's the level that we're talking about with invisible trace. So Pride and Argos will both do invisible trace. SAFER is our smaller, lower cost unit, handheld unit. It has a little bit less range, and it will do what we call residue. So you can think of residue as, if you can actually see the chemical, then that's a small amount. That's what we call residue. And of course, bulk is sugar packets and things like that. So you can see here the detection ranges, the weight of the systems. The nice thing about Argos and SAFER, both of them, is that they are now at a small enough weight or a low enough weight that we can employ them and integrate them into, not only use them as a handheld sensor, but we can integrate them into a ground robot, which I think many of you use in your day-to-day job, and also into a UAV, so that you can get even greater standoff. So particularly with the UAV, because we're the only sensor that has, more than 1 or 2 meters of standoff, you can actually be far enough away from a chemical that you're not blowing it around with the UAV rotors, and you can still do the detection. So we think that Argos and SAFER are going to be very important for bomb squads, for example, that routinely use ground robots or UAVs. Now, what can we detect? Explosives. I mentioned the company started with explosives. We started with a checkpoint explosive detection system, which was 600 pounds. It was meant for stationary checkpoints. But we do detect still explosives and homemade explosives. Here, Pride and Argos will do trace. SAFER will do residue. We can do chemical warfare agents. We have some chemical warfare agents in our library. The chemical warfare agents are primarily detectable by Argos, which is a little bit more sensitive than the SAFER product. We can do narcotics and mixtures of narcotics. We do have 17 different versions of fentanyl, and I know that there are many, many more different versions of fentanyl, but we can put things into the fentanyl family fairly easily with our algorithm. Cutting agents and TICs and TIMs. TICs is toxic industrial chemicals and toxic industrial materials. So how are we going to commercialize this? We would like to do two different things with AMPS. So first of all, as I mentioned, we're very happy with the progress of it. We've determined that this is going to be the algorithm that we're going to use in our production SAFER units and our production Argos units. But we also are looking at the possibility of a standalone sale of the AMPS algorithm so that other sensors can use it. And then, as I mentioned, in the continuation of the SBIRs and the research and development, we would like to be able to take multiple sensors and find the combinations of sensors that will allow you to detect threat chemicals that you might not be able to detect with a single sensor. So as I mentioned, deploy and test AMPS on other sensor mobilities, and we're continuing to develop the machine learning techniques. We think these are very, very strong, and we think that this is the future of algorithms for sensors is going to be machine learning trained algorithms. So let me tell you just a little bit about Alakai Defense Systems. As I mentioned, we started with the checkpoint explosive detection system. It was a 600-pound unit. You can see it there in Korea in the back of a Humvee there. It is a large system. We're actually just about to get a production contract for 10 of these systems, so it is still in production and use. Pride is the 31-pound system. The backpack system, and we have just finished up a foreign military sale production contract for that. And then SAFER, as I mentioned, the production units will be available in September of this year. Argos is probably going to be the middle of 2024. But Alakai Defense Systems basically does one thing. We do standoff, ultraviolet, Raman detection systems. We go from the very big ones to the very little ones. And we do that because there's some physics advantages of using ultraviolet lasers as opposed to infrared lasers or visible lasers. So we want the operator to be able to detect things faster. We want them to be able to stay farther away from the threat chemical. We want them to stay safer. So we do explosives, we do chemical warfare agents, we do narcotics, and we do industrial chemicals. Let me see, I've got two more slides, I believe. Yeah. So some events that we've been to, we were at the SOF Week. We were at a Virginia State Police hosted event that was hosted by the Enrico Police Bomb Squad. up by Richmond, Virginia. We did just finish up the IABTI, an organization some of you may be familiar with, International Association of Bomb Technicians and Inspectors. They had their big annual meeting at Punta Verde, Florida, at the end of June there. That was an excellent show, and a lot of people came to that. And the next event, the next large event that Alakai is going to is in Bratislava, Slovakia, which is actually only about 35 miles from Vienna, Austria. There is a NATO organization called Counter IED Center of Excellence, and they are putting on the EOD demonstrations and trials for 2023. So we're going to go out to that. We are also attending a lot more in the coming year, a lot more law enforcement and bomb squad events from either USBTA or IABTI. Some of you are probably familiar with those organizations. We do think there are a lot of applications for these sensors in DHS and TSA, excuse me, and we look forward to working with you. And this is an acknowledgement. We have had funding from DARPA, from DHS, S&T, and currently funding from the Army Research Laboratory, Dr. Paul Pellegrino. And here's my contact information. Now, we didn't get to show you, there's a video on this website, alakaidefense.com, that I think will be of interest to you. But what it does is it shows the employment of the sensor as both a handheld sensor and on a ground robot, actually 3 different ground robots, and on UAV. So if you're interested in how that might apply to your bomb squad or to your law enforcement day-to-day operations, then I recommend that you come to the Alakai Defense website and take a look at some of our videos. Okay, Chris, we have questions?
All right, great. Thank you, Leo.